All right, geometry. We're on lesson 1.2, undefined terms and definitions today. So this is an interesting, not the funnest concept, but one we've got to do anyway. So we're talking about good definitions. Good definitions exhibit these 5 characteristics in math and terms. All right, so the first one is accurate. Okay, so I have taken those out for you. So you need to write in there, they need to be accurate. So it states that the term being defined and clearly communicates the concept, avoiding ambiguous language. So we're not using all this fluffy language. Okay, that's one thing I do love about math is we don't have a lot of fluff if we can help it. Number 2, the second characteristic is that it's understandable. Understandable. Okay. So understandable means it uses only words that have been previously defined or are clearly understood without, W/O is without being defined. All right, characteristic number 3 is it's reversible. Yeah, these definitions should be reversible to make sense. So it identifies a class to which the object belongs and its distinguishing characteristics. We'll look at this some more in a little bit. It'll make more sense. The fourth characteristic is it's concise, short, sweet, and to the point. So it avoids unnecessary words, but is grammatically correct. You might have to add the CT on there. It avoids emotional words, figures of speech, and limitations of time and space. Oh, wait, hold on. I'm sorry, that's the next one. Number 5 is objective. Objective. All right, and so to be objective, it avoids those emotional words, figures of speech, and the limitations of time and space. So that doesn't tell us a whole lot. So let's practice it. Example 1 says evaluate the definition. So this is definition. Space is the set of all points. All right, so we want to look at, is it accurate? Is it understandable, reversible, concise, and objective? All right, so first of all, accurate. Okay, if we go back to our definition, it states the term being defined and clearly communicates it. Check, it is accurate. It does state that. Okay. And the second part of that was it avoids ambiguous language. So let's see. Let me write here. We'll put check, it states the term, and check, it avoids ambiguous language. So let's put no ambiguous language. Okay. Oops, sorry if you couldn't hardly see that. How about understandable? Is it understandable? So remember, understandable means it uses only words that have been previously defined or are clearly understood without being defined. This one's a little bit trickier in geometry because in this space is the set of all points. Point is definitely a math word, and point has not been defined yet. So understandable, we're going to put point has not been defined. We haven't defined that in class. However, if the space is the set of all points, I'm going to put a note there that set has been defined. We defined that in section 1.1. So that works. That's a good one. But this one is a big old fat X. Okay, the point has not been defined. Okay, reversible. So if we reverse the sentence, space is the set of all points. If we change that and say, the set of all points is space. Does that work? The set of all points is space. Yeah, that's a check. It is reversible. Okay, number 4 is concise. Does it avoid unnecessary words? Okay, so we're going to say, yeah, no. So let's put our check mark. No unnecessary words. And Grammatically correct. Space is the set of all points. Yeah, that's a check too, that it's grammatically correct. And objective. So there, it avoids emotional words. Space is the set of all points. There's no emotion, no figures of speech, no limitations of time. Ha ha, and space. So this one is good. We're really just worried that it has objective. It's objective language. All right. So like I said, it's a little bit weirder to kind of go through there and think about, well, you know what a point is, but it has not been defined yet in our text. All right, so let's go down here to some terms, and this says over there, they should say the basic building blocks for geometry. Here are some terms. So what term is this? Let me read you the definition. It's a dot or location with no length, width, or thickness, a location in space. Yeah, I figured you knew it. It is point. And we're going to draw an illustration of that. So we've got a dot or a point, and we label it P. And we're going to notate that or call it point P, is how we would note it in our notes. Okay, how about the next one? Definition, it's a straight set of points extending infinitely, that should be helpful, in one dimension with no width or thickness. When it says extending infinitely in one dimension, we can go two directions, but only it's one-dimensional. Okay, I thought some of you might know it. It is a line. Okay, and our illustration is, so we've got our line, it's extending in both directions, but it has to have a set of points. So we've got C and D. Okay, so that's why our notation here says line C or D, or we can draw it with CD and the line over it. We could call it line DC or DC with a line over it, or oftentimes they have a name for the line. So this would be line M. Okay, so it's not the point. You can use the points to name it, or you can just call it line M. All right, the last one, a little harder to read. Sorry about that. It's a flat surface made of points extending infinitely in two dimensions. So infinitely. Two dimensions. You might be better off to write that in the white space with no thickness. I tried to make it all work, and I don't know if you can read it when I tried to write over it. So flat surface made of points extending infinitely in two dimensions with no thickness. That's a tougher one. It's a plane. Okay, so a plane and a picture of that. All right, so it has, you might just draw like a parallelogram, kind of, for your plane, so it looks three-dimensional. And it's got some, my lines didn't match up there very well. Some points in there, so we've got F, point H, point G, and just a K up here randomly. So we can call it plane K, just like we had line M, or we can call it plane FGH. There. Okay, so either of those. And again, that says plane. Plane FGH. Always has to have at least 3 letters to name it as a plane, 2 letters to name a line. All right, flip over to the back. We've got collinear points. We need to write a definition this time. So collinear points. Let's look at the definition for non-collinear points. These are points that do not lie on the same line. Okay, so what are collinear points? Check it out, you got it. So these are points that lie on the same line. Okay, linear and line is a dead giveaway. Concurrent lines, those are a little bit tougher. These are lines whose intersection is a single point. So lines whose intersection is a single point. Again, I use a lot of shorthand, so PT is point, PTS is points. All right, so let's look at the example. It says, use the figure to name these three things. All right, so I'm going to go over here and put letter A so I can write them down. So 3 collinear points. Collinear points, remember, are points that lie on the same line. So maybe we've got right here, this point, I was like, this line only has 2 points on it. This line only has 2, but this line here has 3. So it's got point T, point V, and point S. So let's do T, V, and S. All right, B. We want to label 3 non-collinear points. So just 3 points that aren't on the same line. So we could pick T and W. They're on the same line, but then we'll pick a third one that's not. So you could pick S, or you could pick TWR. Or TWV. You have lots of options. All right, and C, 3 concurrent lines. So these are lines, right? Concurrent lines are lines whose intersection is a single point. So we want 3 lines that come together. Well, S has 2 lines that come together. V doesn't have any. T does have 3 lines. Okay, so this is going to be lines. Oh, I don't want my comma there. Pardon me. Lines K, that's line K, is this one. Line L is this one. And line N. Okay, those would be our 3 concurrent lines. All right, notice the little note over here on the side. Any 2 lines are either parallel, which means they're coplanar, they're in the same plane. They're intersecting, so they're in the same plane. Or they're skew, which means they're non-coplanar. Skew means that they cannot lie in the same plane if they're skew lines. Okay, so it might help if we go over some of these definitions a little bit. Coplanar points, then, we need the definition, but we also have non-coplanar points. So those are points that do not lie in the same plane. Well, that should help us with our definition for coplanar points, right? Oh, so what are coplanar points? Excellent. They're points that do lie in the same plane. So points that lie in the same plane. They are coplanar. All right, we have coplanar lines. So these are lines that lie in the same plane. So lines is the word that goes there, right? Coplanar points are points that lie in the same plane. Coplanar lines are lines that lie in the same plane. Skew lines, lines that are not good coplanar. Okay, they are not coplanar because they're not in the same plane. Okay, next up, parallel lines. We're missing a word here. So parallel lines are coplanar lines that blank intersect. Parallel. Good. Do not intersect. The symbol, okay, is those 2 lines very close together with nothing in between them. Not to be confused with your absolute value, right? That has a number or a letter in it. So symbol is here, it says 2 lines, is read is parallel to. Okay. Then we have parallel planes. These are planes that blank intersect. Well, if parallel lines are lines that do not intersect, parallel planes are planes that, yes, do not intersect. Very good. All right, and let's look at example 3 here. We're going to use the cube to name all of these things. Okay, so hopefully my drawing here helps and you can make sense of it. So let's look at A first. So we want to name 4 coplanar parts, or points, pardon me, not parts. All right, so 4 coplanar parts. I'm just going to look here at this plane. Well, actually, let's do a little different one that you might see. Let's do this plane right here. DC, K and L even. We don't even have to do G and H. We can pick K and L. They're all on the same plane. They're just not the vertexes, or the vertices, we would say. So D, C, L, and K are all coplanar. You could add G and H as well and get 6. You don't have to. All right, B, 4 non-coplanar parts. So again, they just can't be in the same plane. So you could pick 2 from the same plane, like A and B. They're from the same plane, but let's pick a different plane. So if we have A and B, then we can't choose F and E, right? Or we could do F. We could do F, and then we could do G. Okay, so A, B, F, and G, they're not all on the same plane. They're non-coplanar. All right, C, 2 pairs of coplanar lines. All right, so let's do this line, AB. So we're going to label it AB. Remember, draw the line over it. I'll never write the word line, AB. It takes too much time. I'm lazy like that. So AB, I'm going to put an and symbol here. And we could do BC. Those are line BC. Those are coplanar. They're intersecting, but coplanar. All right. D, 2 pairs of parallel lines. All right. Oh, wait, hold on. I was supposed to do C. I was supposed to do 2 pairs. Whoops. Let me back up there. So we did AB and BC. What if we did AD and 2 pairs of coplanar lines, AD and EH? I'm sorry about that. Got ahead of myself. All right, back to D. 2 pairs of parallel lines. All right, we could say AB and DC are parallel. So we're going to say line AB is parallel to line C or DC. I want to name it DC because, well, I wouldn't have to, but AB and DC, if I keep that habit of always starting at the same place. Okay, so that's one set of parallel lines. And another set could be maybe BF. Yeah, let's do some vertical ones. Let's do line BF. So line BF is parallel to, so BF is parallel to CG, line CG. Okay. E, 2 pairs of skew lines. So remember, skew, if you need to go back up, here it was. Skew lines are lines that are not coplanar. So they're going to be intersecting, usually, or at least not on the same, at least not on the same plane. All right, so let's see. Let's go back to AB. We've been using that a little bit. AB and so AB, let's do DH because AB goes here, DH is here. Those are definitely skew lines. So they don't intersect. They're just not near each other. All right, another set. How about we look at FG back here, line FG. And let's pick another one that's skew to FG. Maybe you want to pick AE. All right. In your answer, I mean, like you could find others. There's more than one right answer here, right? I'm just picking a set. All right. F is the last thing for our notes. 1 pair of parallel planes. Ooh, we get to name the planes. Again, there's more than one answer because there's lots of planes in here. But unfortunately, there's not a symbol for plane, so I have to write it. Okay, so plane, I'm going to say plane ABC. Okay, and so this does have the D, right? It includes that whole plane, but we only need 3 points to name it. So plane ABC is parallel to plane. Which plane would it be parallel to? Good. Plane EFG. All right. So that wraps up our geometry, our first video lesson. Hopefully that helps you out today, and I'll see you tomorrow. Have a great night.